Well, hello, everyone. Welcome to this session on predictive analytics in action. Hope you're enjoying the AI Engage Summit so far. I'm Timothy Davis. I'm joined by Jamie Boggs. Hey, Jamie, how are we doing today?
Doing really well, Timothy. Excited for this online conference. Excited for the topic and engaging in the chat. We'll be in the chat the whole time, ready to answer questions and engage.
Absolutely. So today we're going to kind of look at how Element 451 drives student success and engagement with AI-powered insights. And so for Jamie and I, talking about these sort of more complex analytics topics, it has become kind of our passion and our work. And it's what we actually do over on our podcast, the EduData podcast, part of the Enrollify network, and you can get it wherever you get your podcasts. But we break down the data that drives higher education. So maybe that's the latest reports that have come out from the different agencies and organizations that do research in this sector and report on it, or breaking down topics like this, like predictive analytics, to sort of demystify how they work and how you can use them in your everyday work as an admissions professional, marketing, enrollment manager, whatever that may be. So with that, let's go ahead and hop into some predictive analytics, talk about first what it is, how it works, and sort of demystify it. Ha 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 ha. Okay, so first thing is to sort of cover the flow of how data gets through a analytics or predictive analytics pipeline, the flow of this data. So first, we need to collect what we call features in this process, and that's going to be like attributes of the student, maybe, or whatever it is that we're trying to predict, maybe the communication. But for our purposes today, we'll mainly be focusing on the student. Then we need to define a target, right? What it is that we want to predict. So that's going to be like the mathematical or data representation of what we want to predict. So maybe that's an enrollment. That's a really common one. Maybe that's persistence or graduation or giving. Could be any number of things. Then we're going to train the model. That's going to be showing it sort of the patterns of the data and helping it get accumulated to how the data is going to look in this situation and help it see the students that did achieve the target and did not, right? And then we can deploy that against our sort of live data and allow it to make predictions for us and use those predictions in a variety of ways. And so we'll look at all of that today. So Jamie, kind of talk us through this process here. Starting with features.
Yeah, starting with features, you're going to want to grab the data that you think matters or that may matter, right? The process is going to tell us what matters and what matters the most. But we're looking to gather data. If we're talking about student success, that success may mean on the enrollment side, finishing an application, enrolling, registering for classes. It may mean persistence, graduation, giving as an alum. But we need to look at that would be the target, and we need to select features that may contribute to that. And we have so many options for where to find our data. You can look in your CRM, your student information system, your LMS, marketing and admissions has stuff, obviously, institutional research. That's kind of their whole deal. And you're going to find something super useful on some dude's spreadsheet that's been at the college for 45 years and just keeps everything. It may still be on pen and paper, but there's some useful data out there that they keep. And you're going to have to kind of dissect how to match it up to what you're looking for. If we're looking on the student level, some of your data is going to be based on a row or an instance per application or per marketing campaign. So how do we take all those different schemas from all those different sources and put it in a format where we can actually measure what those features are? And those features can be behavioral, they can be demographic, and we'll dive into that more in a minute. But there are a lot of different pieces to put in here, and my MO is generally to put anything that could be pertinent in there and then let the model decide what really matters instead of me trying to make those assessments, because there will be things that surprise you. And like I mentioned earlier, you have to define a target and think very basically. The math here is not super complex, right? Look at y equals mx plus b, the slope of a line. In order to put one point in, you get the other point out. Y is going to be your target, and the rest of the formula is going to be your features. So we have the example there, the very simple formula, and the two below it They're pretty much the same thing with more factors built in and with maybe a more complex target. But you need to define, what are we actually looking for here? Do we want to see what leads all the way to graduation when we're getting prospect data? Maybe, but you're probably not going to have enough to predict that. So you're going to want to look at, what is my target first, define that, and then work backwards to the features that may be usable. So you pick your target, and that's going to be the end goal. And you need to work together as a team to figure out what that's going to be. And here's the thing, you can have more than one target. You don't have to just pick, we can only analyze one thing in our predictive analysis. You can pick all the things. It's just going to take more effort, more data cleaning, and more machine processing to get that done. So find out what's important to you and then base everything else off of that target.
Yeah, and I think this really is the slide that demystifies this process, right? Like, it's not magic. AI, machine learning, it's not magic. It's just math. And it's not even like that hard of math. Like, there was a point in my life where I could have solved for Y there. That might have been like ninth grade.
Something like that, probably. Yeah.
And
Yep.
I've definitely lost it since then, but my computer hasn't, right? And so we're just plugging in variables into well-known equations. We're just doing it at a really, really advanced scale. So that's all this process really is. We're just doing that with a lot of data, right? But that target Y, right? We need to kind of have a mathematical representation of what that is, a database representation of what that is. But what we're doing here is those features, right? Of in that second equation, you're seeing that B1, X1, B2, X2. Those are all the features that we've pulled in, and we're just trying to find their relationship to that target Y. And this is how we do it, a linear equation.
I love you saying that it's not magic. I mean, Timothy and I are nerds, not wizards. And that should maybe be a t-shirt for our podcast. Just throwing that out there.
I actually really love that. I think
Yeah.
we found a great motto there on the fly. Well
There we
done.
go.
That's you can't script that stuff.
Right. Then we train the model. So we have all our data together, and the more historical data that you have to train your model, the better. So that historical data set is going to have your target, and that target can be formulated in a few different ways. A lot of times it's a yes or no. Did this individual meet that target? And then all of the features with it for as far back as you can go with relevant, accurate data. So you get all that together, and then you are going to send 70% of that to the model. 70-30 is kind of the standard for breaking up a model between training and testing. You can go 80-20. I don't recommend going any lower than that with the testing, but what the training side does is the machine learning aspect of this, the artificial intelligence, looks at the patterns. It looks at, of the people that are meeting the target, these are the things they have in common. Of the people that are not meeting the target, these are the things they have in common. And the machine learning takes all that in. You see the influence there as it's training on it, and to see what matters, what doesn't. And based on what I've learned about this training set, how can I predict the future? And that's what the test data is for. So after it trains on the 70%, then the model is going to run what it has learned to anticipate the outcomes of the test set. And then we're going to look at how accurate was it. It's going to predict the target outcome for every individual in that test set. So what were the actual outcomes and what were the predicted outcomes? And you're trying to get a high level of accuracy there. You don't want 100%. That's usually overfitting. Even 95 or above is kind of, you need to ask yourself some questions. Living around that 90, 85 range, I think is usually pretty solid. But this is the general process of the model training, and that little box of model training has a lot more in it than just one little blue box, right? Like the machine learning aspect of it, and there are different tools that we're going to talk about in a minute that you can use for that. But this is the process for the model learning everything it needs to learn to move forward and accurately predict on your live data what are the outcomes going to be on that target.
Yeah, just to hit that home, right? This is not live data. This is historic data, stuff that has already happened. And it is a situation in which we know the outcome. We know why, whether or not it happened. So if we're trying to predict enrollment, we know for all that historic data in the bottom left there, we know whether or not they enrolled, or we know whether or not they persisted. And what we're going to be doing in this process is looking at all the other factors, all the other features of the contact here, the student, and determining how those influenced whether or not it enrolled. And that's really going to affect our output. And like Jamie was saying, if we get really good at predicting that, the model gets really good at predicting that, right? That's where it becomes sort of usable and where we start to get good outputs. So let's talk about that next.
Yeah, the output you're going to get is basically a likelihood to achieve the target, a propensity score, if you will. So you can see that the live data goes in, so new data with our green people feed into the model that's been created using the factors that you can see there. And those are just examples. We'll talk about the factors or features more in a little bit and what we believe is the most useful and our models have shown are the most useful. And you get this likelihood, in this case, to enroll. So you may have people spread all across the board in your likelihood to enroll. And then this is where you make the decision on what to do with it. If we have people who are really likely to enroll, 80 and above, maybe we send them some kind of closing the deal letter, or we say, you know what, they're probably coming. Let's focus on that middle range. And maybe if somebody's 1% likely to come, maybe you decide not to utilize financial and time resources to interact with them to try to move that needle. Now, again, these are predictions. We could end up with the 18% person enrolling and the 81% not, of course, because this is a likelihood and a prediction. But these are the outputs you're going to get. And then you can decide what to do with it. It is actionable, but how you're going to act on it is probably a completely different conversation depending on what the target is, depending on what part of the recruiting season it is, if that's what you're doing, what part of the grading system it is, if you're looking at student success on campus, dean's list, getting off of probation, persisting. So it's variable how you're going to interact, but this gives you the outputs you need to make those decisions.
Yeah, and again, that's it, right? The output of this thing is not a definitive statement. We're not declaring the future, right? We're not willing it into being. We are just predicting what it could possibly be. So that's the key of predictive analytics, right? Is that this is just a prediction. You get that back as a percentage score, and then you also get to see what factors were the most meaningful, right? So what does that look like?
Yeah. So the feature importance, I think, is huge when you look at the things you're actually putting in. Again, these are the features. These are the predictors. So we can put some demographic things in here. You see ethnicity in there. You see postal code. But there's also behavior data in there of clicked on 500 plus emails, or selected a major, or changed their major, or enrolled in an extra class. It can be whatever it is, behavior or demo data. But this is going to tell you what's most important. And it's super useful because you can see, for example, if this showed that a campus visit was the most important factor when it comes to enrollment, then like we need to drive those campus visits. We need to get people on campus. That seems to play a big role in them coming to campus. Now, this is probability, this is correlation. So it may be that people are going to come for campus visits, but you have to use that as you see fit. And you may see that, our mailers, our postcards don't have any weights in this for people who have received a postcard or what have you. So you can make decisions based on this as well. But the breakdown is going to vary. You may see a really strong top 5 and a big drop off. You may see that most things are pretty close together of this really is a total package of data going in and everything matters at least somewhat. So let's take a more holistic approach to our student support or our student recruitment, whichever side of the house you're on. But this allows you to see what matters. Because I think a lot of times we'll look back and say, well, my boss, when I first started, really loved this and this, but maybe this and this doesn't matter anymore. And this can tell us that.
When I worked on campus, if I'd come back with a predictive model and showed feature importance that said that the campus visit was the most meaningful mover in predicting predicting enrollment, my enrollment manager would have done a backflip. Like, I knew it. If we get them on campus, they'll be here in the fall. Absolutely. So that absolutely could confirm their bias there. But there is kind of where I want to introduce that topic of bias, right? So what we're dealing with here is historic information, what has been successful, or maybe the factors that have determined the students that have enrolled, right? And this is an area where bias can be introduced, right? As we see, one of the top there in that chart is ethnicity, right? So we're talking about the students that have already enrolled in the institution, and so if we don't take into account these features, right, that may bias our future decision making, right, and lead to more of the same, right? So perhaps that's not what our institution's goals are. We need to be mindful of those things. Okay, when it comes to actually deploying, though, these sort of predictive analytics tools, right, that becomes a little bit more complicated, right? And there's been a lot of movement in the industry to make this a little bit easier, but there's lots of ways that you can do enrollment analytics, right? So the first one is that it can be done in Excel, right? And so your institution might even already be doing some like forecasting, which is a method of predictive analytics on, like, budget or resources, and we'll kind of look at that again in a minute. But doing that in Excel is possible, but there's like some hard limits when you're kind of doing that locally, right? If we're talking about hundreds of thousands, maybe even a million contacts, and we want to make a prediction about them, Excel is probably going to crash. It's probably going to actually put your computer down. So don't try to do that locally. So there are other tools that allow you to do that. A lot of those utilize like cloud computing. So you're using Microsoft's Azure servers or AWS, Amazon Web Services, right? Which are basically just big computers out there in the world somewhere that you can utilize for a specific task to be able to crunch a lot of data. So that's where a lot of this computing actually happens, as opposed to like on your local machine or even on like a local server at your institution. Your institution might have local servers called like on-premise servers that are doing various things, maybe storing really sensitive student data so that it's not like exposed out into the cloud. Or there's a lot of reasons why you might utilize an on-premise server, but predictive analytics is probably not one of those uses. Could be, but man, you'd have to have some like beefy computers down in the basement there. So
Yep.
the utilizing cloud computing has been one of the moves that predictive analytics workflows have taken advantage of as they've sort of scaled up. And kind of capitalizing on that, a lot of these service providers have tried to make predictive analytics workflows a lot simpler. So as opposed to like writing out all of the code for your model, right, defining all the different features in a coding language like you might do like with Python. There's a lot of like what are called like packages for Python that let you access formulas and access configurations to train a model. Services like Snowflake have actually tried to make that as simple as just like plugging in one table into a formula, right? So you're just passing it straight into the entire formula. You're not having to define all the parameters or anything. You just kind of hand it off, and behind the scenes, Snowflake's pre-built functions and formulas do all the magic. And that's actually how we've leveraged predictive analytics at Element 451. We use Snowflake as our data warehouse or data platform provider for analytics. And we've utilized some of these functions to just spin up predictive analytics models fairly quickly.
And this is evolving. Snowflake's utility for this is fairly recent. So we've used BigML, we've used Python, and maybe your campus is a Microsoft campus. So Azure is going to be your go-to. And there are going to be new tools coming out regularly, I believe, with this ability. So this is an evolving list for certain. So just see what your campus uses and maybe what's going to make the most sense for you financially and workload-wise.
Absolutely. So now that we've hopefully kind of demystified predictive analytics, let's move on to actually how to use these predictions, right? We talked about how those predictions are returned as a percentage, right? Or as a floating sort of decimal point. Let's see how we can actually use that in our day-to-day engagement with students.
Absolutely. So this is the gaining insights part. Like, this is the good part. This is, okay, what do we do now? And we're going to talk about a few different aspects of this, forecasting media spend, how you optimize your communications, and then how you allocate resources. And like Timothy said, forecasting, you can do some of that in Excel, but there's also a lot more available. Talk a little bit more about what we can do to forecast and how that's helpful.
Yeah, yeah. So your institution might already be doing some forecasting at a really high level, so they pull in like, our total enrollment for this term, our total budget spend for this term, and kind of roll it up to like a high level of aggregation is what we would call that. And then in Excel, you've got, 15 lines of previous years or whatever, and then you can sort of forecast out based on what we've seen so far, our fit of what our enrollment and our budget is going to look like is between, this high number and this low number or whatever. So we need to plan kind of accordingly for that. That's a high level sort of forecast. But of course, you can apply those forecasts at a much lower level of aggregation as well. So you could like predict or forecast how many like applications you might have for a given like week, that sort of thing. But you'd be doing that at the contact level as opposed to at like the term or academic year level. So there's one possibility there. But another one that's a little bit more interesting, maybe to our marketing side, is media spend and how we do that.
Yeah, in previous lives, Timothy and I both worked in marketing, and I became really familiar and comfortable with media mix modeling. Basically, you're breaking down the spend per channel, per month, per week, per cycle, whatever, and measuring that against the target of it could be impressions, it could be inquiry forms, it could be applications submitted, what have you. But that way, you're actually putting in the dollar amounts that you're spending per channel and measuring that against your target to be able to see what channels are driving the awareness. And you can have, again, multiple targets, run it a few times to see, well, we know TikTok's driving awareness, but in the big picture, it's not getting us any more apps. And what combinations of channels matter? Maybe that's going to be super seasonal, and you'll be able to see that if you keep this data in a weekly or monthly schedule to see, well, it looks like TikTok in August is super helpful, but it's kind of a waste in May because we're still increasing awareness, or at least for this current class. So media mix modeling can be huge for you to develop the best plan for utilizing your money, and temper your expectations or raise your expectations. You may see, you know what, the more money we put into LinkedIn, the more grad apps we get. So let's put more money in and expect more grad apps to come in. So it's a balance of measuring and getting the raw data out, and then using that to adjust your goals to reflect what's actually happening. Like I said, your predecessors, your supervisors, or maybe you have held on to these beliefs for a long time. But as the data says something different, you can adjust your goals, adjust your reporting to be more accurate, and of course, to be more efficient, which is what we all want, right?
Absolutely. Another way that we can do this is by kind of understanding what our students are into and optimizing communication for that. So if we can kind of quantify how or what sort of messages our communications are utilizing and kind of bucket those into general categories, or have variations of a message in a specific category, right? We can test those to see how effective they are against a particular contact, and then eventually predict what message a student might be most likely to resonate with, right? And really make our communication a lot more effective. This is like hyperscale personalization. It's way beyond just putting the first name and the major or whatever of a student in an email to them. It's really modeling out how a communication message might be impactful to them. So something to think about there.
And of course, everything comes down to time and money, right? Those are our resources that we have, and personnel obviously is both of those. So is marketing. The time spent on projects is time is money, right? So this is going to allow you to take the data and to make better decisions about how you're spending your time, how your staff is working. For example, if we're talking about students in academic difficulty or students on academic probation, the study may show that, hey, a detailed study plan may be the thing that moves the needle for a certain group of students. You can use artificial intelligence to take data in and write up that plan. And now you know how important that is. You find a way to do that efficiently. You've saved yourself a ton of time and made a big impact. On the marketing side, make sure you're not throwing dollars at channels that aren't super helpful, or make sure if phone calls seem to be irrelevant in recruiting, let's spend our time doing something else, because those are it takes a lot of time to dial all those numbers in the way that we do, in the way that I used to back in the 1900s, right? And how are we spending our time? Are we going to spend a ton of time in meetings talking about this and arguing over these things? If we get this data in front of us, maybe we don't have to do that anymore. So we're saving our resources again to be more efficient, to show our supervisors, our admins, hey, we're getting better at this and we're meeting our goals.
Absolutely. And so at Element 451, we know that maybe spinning up these predictive analytics models is a bit tricky. It's not something that your average admissions pro is going to knock out in an afternoon. And so we've tried to bring those into the platform by default for you, right? So that they're automatically working there and you can access them for segments or for other useful things. And the first one that we've actually that we're coming up on deploying is called the Bolt Priority Index. We're really excited about this because it uses some of the data that's really specific and proprietary to Element to make a really good prediction about a student's likelihood to progress through the funnel at multiple points. So the data that we're using for them obviously is that anonymous and permanent demographic information. So all the stuff that you're used to seeing and talking about when we talk about demographic information for students.
And at Element 451, we have proprietary data of anonymous behaviors that we have in bulk in some ways. So that's really helpful at having more historical data to train the model.
Absolutely. So how then are contacts classified? How do we actually make this, available within the platform? Instead of delivering like that percentage number, right? We actually roll that up into a couple of different categories that you can create segments based off of. And so you might like go after your sort of steady or warm folks first, as opposed to your prime folks. And so this is a way that you can allocate different resources. Maybe the prime folks only get a low touch from the admissions staff side, a low touch call to action, where warm and steady, like they're driven to, schedule an appointment or come to an event, things like that. So that's how we kind of obscure that a little bit more or make it less complicated when you're actually using it in the platform. So when it comes to the Bolt Priority Index, we're obviously using machine learning to do that. That's a constant process that continuously goes. We're obviously took data security and personally identifiable information very seriously. We're not feeding that to any third-party models. It's not training anybody else's data or becoming data for anybody else to train on, that sort of thing. And then, of course, we're using that behavioral data. And then, as I mentioned, we can use that in a variety of different places. The really interesting one, the two that I want to mention really quick are tasks, right? So we can prioritize the tasks in the platform based on the student's priority index. And then we can also use that priority index as a prompt for staff assistants. So in Element, we have AI staff assistants that can comment on or tell you about a contact, make recommendations on how to engage with the contact, write communications for them. We can provide the priority index to the AI to the LLM while it's making those recommendations. So those are some of the exciting ways that we're bringing predictive analytics into the platform. But Jamie, talk to us just briefly as we wrap up about looking to the future for predictive analytics in Element 451.
Just like everything in tech right now, this is rapidly evolving. We're capturing new data. We have access to new data. There are new interactions that we're able to track online and within apps and within Student Hub, which is coming to Element 451 soon. We're getting new tools, AI to refine the features, AI to interpret the outcomes, and improving the speed of what we're doing and automating the automation, right? We're getting more and more efficient, and new use cases. Use predictive analytics to inform your AI conversations like we do in our Bolt AI assistants. If we know that somebody is a prime student to enroll, then we can interact with them differently and allow our AI to do that. Using previous features as new targets. So if submitting an app was a feature for enrollment, maybe let's back up and see what leads to that as an outcome so that we can progressively get better. And then finding new targets you've never considered. Things are changing. New things are going to exist that can be an important target that didn't exist 5 years ago. So let's stay up to date on what those things look like.
Absolutely. Well, hey, again, thank you so much for joining us today for the AI Engage Summit and coming to this session here. Hope it's been interesting to you. As always, please feel free to check out our podcast, the EduData podcast, wherever you get your podcast, and check out all the other shows in the Enrollify network as well. You can also reach out to us on LinkedIn and connect with us there. And we'll be at some of these other sessions, so you might see us in the chat. But again, for Jamie Boggs, I'm Timothy Davis. Thank you so much for coming today. We'll see you in the other sessions.